All right. Let's go through the questions, guys. All right. So there's quite a few problems here. There was a 7120 and 7124 and a bunch of other ones after that. So 7120 says examine the diagram at the right. So you have a triangle, right? And then you draw a mid-segment. Remember, mid-segment is when you cut the sides in half. So RH is cutting SK in half. It's also cutting SA in half. So are the triangles in this diagram similar? Of course they'll be, because the sides are proportional. Like SR is half of SK. SH will be half of SA. Therefore, HR is half of AK. And also you have right angles, right? And they share angles. So you totally could get away with angle-angle similarity to prove it. So this means that the sides are proportional. All the corresponding angles are proportional. So relationship among all the sides is 1 to 2, or 2 to 1, however you want to call it. And if SK is 20, then SR would have to be 10, or RK would have to be 10. If RH is 8, AK is going to be 16. So actually, I'll draw this on the screen right now. So if this is 8, this has to be 16. Because they said RH is 8, so it's 1 to 2 ratio. And this whole thing here is 20. If you do Pythagorean theorem, this should be 12. It's not to scale, but it should be 12. And therefore, each of these are 6. That's why you get 6 for SH. So hopefully that makes sense for that one. That's just, using properties of triangles. And we know these are true because of our proofs we've done. Here's an actual proof. Whoa. We caught that on recording. All right. You okay?
Yeah, I'm good.
Good. All right. Awesome.
No, it's sometimes it's loud, sometimes it's quiet.
Okay.
It's very loud.
All right. Yeah. All right. Well, if you guys were asleep, now you're awake. Good. AD is parallel to EH. BF is parallel to CG. Okay. What are you trying to prove? You're trying to prove that angle A equals angle D. So we just talk it out, right? I know A and B are the same, right? Because they're alternate angles, right? So I know that. I know B and C are the same. Why? Because those are corresponding angles. Because we've got these lines parallel, these lines parallel. So also I know C is the same as D, right? Those vertical angles. So it's kind of this chain reaction. A is the same as B is the same as C, so A is the same as C. C is the same as D, therefore A is the same as D. So you're doing all this substitution. A is the same as B, we know alternate triangles. A is the same as C. Actually, we need to say this. That's wrong. You gotta say step 4 before step 3. B is the same as C for corresponding angles. So you gotta say steps 2 and 4 before step 3. That was off a little bit. And of course, if A is the same as B and B is the same as C, A and C are the same. C and D is the same as vertical angles, and we use substitution one more time. So substitution is just you're replacing a letter with something else that it equals. That's all you're doing for substitution. So for example, if you say A equals B and B equals C, naturally A equals C. That's all substitutions ever is. Because what you're doing is you're replacing this B here with what? Nothing it equals, which is A. There you go. Okay, for 7131, Tamika, I can't read that very clearly. Remember that the diagonals of rhombus are perpendicular. We know this. So you plot those points. Is there a rhombus? The best thing to do is to find the slopes and see if the slopes are negative reciprocals of each other. Like, for example, if you get 2 and negative 1/2, that'd be okay. Find the equation lines on which the diagonals lie. That is, find the equations. Once you have the slopes and a point on the line, I'm sure you guys are fine doing that. The equations are right there. And of course, compare the slopes, they're negative reciprocals. So there we go. The other thing about a rhombus too is that each side has to have the same length. So you could have done that as well, instead of find the slopes of the diagonals. But you could do that too and make sure negative reciprocals. That would prove it. Here, that's easy. Find the midpoint, just average of those coordinates. That's not that hard. For 134, GH is obviously half of IJ. So you got double GH to get to set equal to IJ and solve for X. For 136, you got a square there. And try and find the perimeter, work it all out. So all is good. Okay. Here's the Pythagorean theorem. Do this trick for part B. Part C, yeah, more trig. You got to do the inverse trig functions. We know how to do that. D, you got a word problem. You have the hypotenuse, you got the base angle, this angle of elevation using a clinometer. How high is Juanito's kite? You could use a sine function. We'll do that. So just review trig again. And lastly, for 137, must be, could be. Here are some more challenges from Mr. Quincy for each description of a quadrilateral below. Say what special type of quadrilateral must be, and enter what special type of quadrilateral could be. Look out some because may have no must be's. Wait, what? Oh, must be this. Got it. And some just make, could be that. So, for example, my quadrilateral has one pair of equal sides and one pair of parallel sides. So, and I guess it's not the same pair, so it would have to be an isosceles trapezoid. If it was the same pair, then it definitely could be a parallelogram. Because a parallelogram, those would be parallel and those would be the same. But if you have only one pair of parallel sides, and the other pair are the congruent sides, then it has to be an isosceles trapezoid. The diagonals of a quadrilateral bisect each other. Parallelogram definitely does that for sure, but it could be special. It could be a rhombus, it could be a rectangle, it could be a square. A rhombus is a special parallelogram because all the sides are the same. What makes a rectangle special? What's unique about a rectangle compared to a rhombus or a parallelogram? What do you see about all the angles? That was because a rhombus doesn't need that, right? Now what makes a square special? The square is the most special of all these. All equal and right angle. So it is a rectangle and it is a rhombus by definition. Happens to be a special rhombus or a special rectangle. But is a rectangle a square? Not necessarily, right? Is a rhombus a square? Not necessarily, because you need to have those right angles. So we're okay with that? Cool. Awesome. Okay. So that's the homework review. So what you guys can do next is wrap up your posters. I know some people are all done, so you can just hang tight for a little bit. Who still needs to finish? A couple groups. Okay. So the other groups could just hang tight for a little bit. And actually, I think Faith, you gotta go at 150. Oh, 215. Okay, so I'll have you probably present first then. Okay. All right, so the posters are actually, hold on, let me please go into the space. Yeah, but I think this thing there's separate pairs. So, one pair of parallel sides plus zero congruent sides. So you have to vote, you have to have all four sides. Yeah.
So it doesn't look like. I also it's out there side.
Yeah. You said exactly. That's a pair. I can seriously, this is at least one pair. So it's a little confused. I don't like the wording of that, because I think it should say. I think this sum just exactly. Okay, so here you gotta go.
Yeah.
Okay, no worries.
Have to like.
Well, Maggie and Peter, you guys can finish up. You just mind me for the declaration. So I'll leave it right here. Actually, Peter can move.
Yeah.
Yeah.
Do you like our theme? Bible street, red street.
And
There's a lot.
oh, there we go. Okay, so Reagan, Sabine's wrapping up the quiz, so you could finish it up. Yeah, do you have the Griffiths up? Has it? Oh, I have it actually. Sorry, I have it. I apologize. Here is this one. I'll put you over here. Okay, and
There's Sharpies.
Sharpies, yeah. Hold on, I got to. It's not, you're all done, right? They're fine too. You need a. Are you all done? Great, perfect. You guys can, yeah, you can do that, then you can wrap it up.
Sorry.
Yeah. It's probably the best to have. I'm not sure if this will work. It's a fine tip though. I don't know if I have, let me check my backpack. Pause this recording. Okay. So, you're given a parallelogram, A, B, C, D, E. Okay. Sorry, A, B, C, D. Sorry, that's only 4 letters, A, B, C, D. And you're told angle A and angle E are the same. You want to prove that CD and C are the same. So one way you can go about this is we'll state the givens, of course, right? And if you have a parallelogram, you know you're gonna have sides that are parallel. From there, you know something about the angles, and you should be able to have this chain reaction where you can make some sort of statement about triangle CDE, and then state the final thing. So, but I don't want to talk too much about it because we do have a group who worked on it. So, let's have Faith, Colette, and Cam, if you guys want to come up and just paste it. Yeah, and I'll mute that. There we go. All right, yeah, so talk to us.
Okay, so we just like explain the proof?
Yeah.
Okay.
So what are you given? What are you trying to prove, and how did you prove it? So what are you given?
So the president is a parallelogram,
Good.
and then what? Okay, we drew president adds but so
Well, what else are you given?
we're given the A parallelogram, and then angle A equals angle E.
Okay. Well, where's A and E?
Angle and E is this angle.
Okay, good. And look to them. How this? I will stand this way, so that way you don't have to look to the side. You can look out this way. Much better.
You know that those are equal and that the present is a parallelogram. You have to prove that CD, which is this tree line, and CE
So you're trying to prove both tree lines are the same.
are the same.
Good.
So
Okay.
do that, we should prove that the tree is like an isosceles
Yes.
angle.
Good.
And to do that, we could prove it by saying that the two angles in the triangle are the same.
Okay, good.
And we know the two sides are the same. So
And you guys got that when the two angles of a triangle are the same, the sides opposite must also be the same. But how did you get the two angles being the same?
okay, so we identified that like this shape is a parallelogram, and then like using and then all of like AB is parallel to BC and like so on.
And BC is parallel to AD. Yeah. Actually, AB and CD. That's good. You want to say that for sure.
Figure out like which angles are congruent and stuff.
Okay, so for example, you have the left side of the parallelogram parallel to the right side of the parallelogram, right?
Yeah.
Good. And then what angles are the same because of that?
A angle A
Good.
are the same. Alternate.
Oh, actually, corresponding angles.
Substitute.
Yeah, because if you know that A and E are the same and A and D are the same, then D and E have to be the same, right? And then therefore that's enough to prove that the sides opposite also the same. Okay, cool. Okay, you got it. Cool. All right, and you can just put it back on the little whiteboard over there. All right, good. Okay, now we'll go with
We see what we guys have budget pulled up here. Pull up whiteboard. Is you guys, you get like. Am I?
Well.
Okay, so before Connor will talk about their proof, just so you guys know what they did. They also had a parallelogram. And they're also angle 1, angle 2, where you see angle 1's like off to the left, angle 2's off to the right. And they had to prove that MI and KE, these shorter sides, are the same. So probably they're gonna have to prove the triangles are congruent and then do a CP/CTC situation. So I'll let you guys, I'll mute that. You could eject it or paste it. All right, so again, what are we given? What are we told?
We are given that angle 1 is congruent to angle 2.
Okay.
And we're given the MCAY.
The whole thing's what?
Is a thing.
Good, okay.
And then you're told to prove that MI, the segment is congruent to KE.
Okay.
So first we have the given.
Then we have YM is congruent to KC, and we know that because if their angles are congruent, that means their opposite sides also have to be congruent.
Well, actually, hold on. So where's YM? Off to the left. And where's the other one? And where's KC? So those are opposite sides of the parallelogram. And what do we know about opposite sides of parallelograms? They're going to be the same, yeah. So we don't have to do anything with triangles right now. So, but that's good. Okay, and then what's the next thing you could say?
Then angle.
And that's another property of parallelograms, right? Angles opposite each other have to be the same. And then what happened after that?
Angles and sides to say that a triangle.
Good. Perfect. Good.
So yes.
Actually, it's ASA. Oh, it's okay. It's all right because of angle side angle. And yeah, you might want to fix that. So I'll let you fix it after you finish presenting. And then lastly, once the triangles are congruent, what can you say after that? Good. Perfect. Okay, good. Perfect. Yeah, just fix the fourth statement. Just change the ASA and you're good. All right, thank you. All right. Okay, so then we can go Sabine and Reagan, and then what proof you guys had? You guys had BCDA. Let's see here. What was that? Sorry? Oh, that's okay. That's fine.
Oh yeah, Augusta was also interviewed with you.
It's all good. So it's okay, cool. You guys got a fun one. Okay. So just to recap what they did, they had to prove that this triangle is same as that triangle. And in order to do that, no, your diagonal looks gorgeous. It's good. But yeah, but you know, they have to prove some sides and angles are the same. So I'm gonna let them take it away. Oh, yeah, there you go. Okay. So yeah, so what are you giving again? Okay. Actually, if it helps, I could do this also. There you go. So where's BE?
Oh, B.
Mm-hmm. Okay, good. Okay.
And then EF is perpendicular to AC, so it's like that.
Okay, so when you got two lines that are perpendicular, what does it tell us about the angles?
Over it.
So you got right angles, perfect. Okay, good. Okay, good. So definitely we'll need to use that knowledge if we have right angles. That helps. And then what else will help us?
Parallel to AC. Definition of parallelogram.
Good.
Like the two sides.
Actually, they're gonna be top BC. Yeah, so those are the top and bottom sides, okay? So when they're parallel, then what does that tell us about the angles? And which two angles are the same? You can just point to them. Well, BC is the top side, right? And AD is the bottom side. And you have that diagonal that goes right through the middle. So what alternate interior angles are we looking at? Yeah, that one right there is the same as which one? Perfect, good. And then what do you know about the the top and bottom sides? Good. So keep going.
AB, so this blue triangle is congruent to BCB, which is this yellow triangle. Because of the alternate interior angles. For the parallel ones.
But what's the congruence statement for that? Because like how many angles and sides have you proven? Yeah, good. Because you have the right angles, the alternate interior angles, and then the sides afterwards, and the sides not in between the two angles. Okay, so that's another way you could prove triangles, right? AS. So cool. Okay, good. Thank you. All right, and then I know you guys are still
It'll take us like 2 minutes.
2 minutes. So let me do this then. While you guys are wrapping up, let me just briefly talk about these new handouts that I want to give you guys. And then yeah, I didn't give out the new handouts. I just gave the homework. It should be right here. Or I put it on that desk, I think. I got extras. Hold on. Okay, so let me do this really fast. Let me turn this back on again. Okay. All right, you guys don't have access to this. Let me pass this out right now. I'll leave this for you. Okay, so this is what we call a quadrilateral flow chart.
Or the smudge.
Yeah, not what's the color top? There's some streaks top. Yeah, I think you're pretty good at that.
Thank you.
This for Julie's is used to be mine, so. And you see them, you want that line, so. No, no, my head.
We'll be done in about like 30 seconds.
Take your time. Okay. Let me briefly talk about the flowchart you guys just received. Well, I'll just go, then you guys can go after I'm done. Okay, so a quadrilateral flowchart. Here's what's happening. It's kind of like a hierarchy, if that makes sense, or like a totem pole or food chain, whatever analogy you want to throw in there. So you have like something that's at the bottom of the totem pole or bottom of the food chain, even though it's kind of at the top on the diagram. The quadrilateral is the most basic four-sided polygon you can think of, right? Just any shape, four sides, we call it quadrilateral. They can become more special depending on what's happening among the sides and angles. So a trapezoid, as we know, has one pair of parallel sides. A parallelogram has two pairs of parallel sides. A kite has no parallel sides. But what makes a kite special is you have two pairs of consecutive congruent sides. These two right next to each other congruent, these right next to each other congruent. Parallelogram, again, you have two pairs of parallel sides. Also happens that both pairs are congruent to each other. You know, one pair is congruent to one, top one's congruent, left to right congruent. Trapezoid, left right sides could be congruent, they don't have to be, but you have exactly one pair of parallel sides. Now, a more special trapezoid is an isosceles trapezoid. That's when the non-parallel sides are equal. Kite's a kite, but for a parallelogram, it can be special if all four angles are equal or all four sides are equal. That would be a rectangle rhombus respectively. And if you get both angles and sides all the same, then of course it's a square. So that's just the hierarchy of that. And then here's a little flow chart you could use for classifying quadrilaterals and coordinate system. So if you use like distance formula or slope formula, we know all those things. You kind of start with how many pairs of opposite sides are parallel, no pairs. Then we'll go down that flow chart. And of course, if you could have a kite, if the two sides congruent to each other are the same, use distance formula. If not, just plan with quadrilateral. If you have one pair, it could be a trapezoid or a sausage trapezoid, depending on if the non-parallel sides are congruent using distance formula. If you have two pairs of opposite sides that are parallel, then you could have then you have to ask yourself, hey, are the diagonals congruent? If they are, then you know you have a parallel. You could potentially have a rectangle or a square. If diagonals are congruent, then and all four angles are and the diagonals are perpendicular, that's a square. If they're not, that's a rectangle. If diagonals are not congruent, but they're perpendicular, that'd be a rhombus. Because when you have rhombus, diagonals will not be congruent. Or if they're not congruent and also not perpendicular, you have a parallelogram. So basically, looking at the diagonal, that's kind of a big deal as part of this flow chart. You can skip the flow chart here if you can show that if you show the definition is true. Yeah, if you could show that yeah, like for slope formula or distance formula, all those things. Yeah, so anyhow, that's just a flow chart there. So I just want to make sure you guys have access to this. You guys have the new homework packet also. Homework looks like this. It's just gonna be more of the same worksheet that we had 2 homeworks ago, I think. I can't remember. I think it was homework 7. It was homework 6. Where you're given some properties of a quadrilateral, you have to find all those other things. So you have all this here. I also published the answer key too. Don't do all these problems, by the way. Look at the instructions 1 through 4, 9 through 12, 7 through 20. And you could choose either 26 or 28. It's a proof. You can choose which one to do. And I believe the answer key will show that. Let me pull up the answer key really quickly, and then we'll have Peter and Maggie presents. Homework. Answer key. Yeah, it shows both proofs for 26, 20, and the answers for 1 through 4, 9 through 12, and I think 17 through 20. Yeah, cool. Let me download that so I have it accessed. All right, excellent. Okay, last proof we're going to talk about. You guys are proving. Okay, see the last step. Is it B, D, and C? Okay, so this is the proof they did. B, D, and C, E. Okay, here we go. So this is the proof they did. They were given that ABC is a parallelogram. So the diagram off to the left, D is the midpoint of AE. They had to prove that BD and C were the same. There's actually a few ways you could do this. You could probably do triangle congruence. I think there's another way they went about it. I'm gonna let them talk about it. So yeah, I'll just turn this off. There you guys, last one. Here we go.
Okay. So I came with a proof pyramid. And basically we were given that ABC
This one.
okay, it's a parallelogram and D is the midpoint of AE. So then we said that AD and PD are congruent because of the definition of the midpoint. And then we said that AD is parallel to line DC. Because of the definition.
Should be BC.
AC, yeah.
Oh yeah, sorry, that was
You can fix that later.
because of the definition of parallelogram. And then we said that angle BAD is congruent to angle CDE. Because of corresponding angles are
Good.
congruent for parallels.
Then
And then this is parallel to that pyramid.
because of side angle side.
Yeah, well, we also have AB is the same as DC.
Oh wait, yeah, I forgot that one.
Yeah,
AB is equal to DC.
because the opposite sides of parallelogram are the same.
Yeah.
Okay.
And then right, we have that one because of SAS.
So basically, what sides are this? So you have AB the same as DC, so you point to those.
AB is the
Mhm.
same as DC.
And then what else is the same?
And this angle is the same as this angle,
And then the sides.
and then the other sides were,
Good.
That's
And then the last thing.
And then this side, not side, are the same because of CT, CT,
Yeah, because you have to prove hold on, BD is the same as
CE.
CE.
So they're applying to the same.
Yeah, actually, that's not a CPC. I think that's going to be hold on a sec. Oh, it is. Yeah, I'm tripping. No, you're right. Yeah, sorry. Of course. Yes, it's also part of parallelogram. My eyes are playing tricks on me because your diagram is like so
That's
Yeah.
right.
so intoxicating. Okay, no, but yeah, it is the right sides of each triangle are the same because of CPC. Got it. Cool. Good. Okay. Beautiful looking proof. Good. Okay, great. So yeah, we're done now. So we got about 10 more minutes. So you guys could get a head start on homework. I'm not going to do any more learning today. You guys have had enough learning for the day at school. So you guys can put it back on the whiteboard in the back, and then I'll put them up elsewhere. Sure. Yeah. Just make sure you make that proper change.